Okay, this is the second lesson in our kinematics unit, equations of motion. Two main ideas. The first main idea that there's 5 equations for uniformly accelerated motion that involve the variables displacement, initial velocity, final velocity, acceleration, and time interval. The second main idea is that free fall is the motion of an object when moving only under the influence of gravity. The acceleration due to gravity at the surface of the Earth is 9.8 meters per second down or towards the center of the Earth. Kinematic equations. I have 6 written here. The first 2 are really just the same equation, just sort of separated apart. You have your displacement is equal to your average velocity times time. Your average velocity is the sum of your first and last velocities divided by 2. All the time, constant acceleration. The third equation says that your final velocity is equal to your first velocity plus acceleration times time. What that's really saying is that your final velocity equals your first velocity plus your change in velocity, because acceleration times time is equal to your change in your velocity. This equation here, this is the equation that you will use when you don't need time and you don't have time. This is the equation that most students find they need when they're absolutely stuck on a problem. 9 times out of 10, it's that equation. These 2 equations come from graphical analysis of motion. We derived that last year from the area underneath a velocity time graph. It says that the displacement is equal to your first velocity times your change in time plus 1/2 your acceleration, your time squared. The other way of thinking about it is that your displacement is also equal to your last velocity times time, take away 1/2 acceleration time squared. Now, there are 3 questions in this unit we'll take up. The first one being, a ship sailing west coasts to a stop in 0.5 hours and sails 10 kilometers in a straight line. What is the average acceleration of the ship? Well, all problems, you should always write some sort of axis. One way is positive, one way is negative. When you're dealing with just linear vectors, this is the thing to do. Here, we don't know the acceleration, that's what we're solving for, but we do know it's this way, and by our way of measuring, it's negative. Our first velocity is going west. We don't know what it is. We do know it's positive. We do know the second velocity, even though they didn't say it straight out. We know it's 0 because it stopped. Don't forget that. That's a lot of students have problems because they forget this. The displacement is plus 10. So I have plus 10 kilometers is equal to 0. We like zeros. That whole term goes to 0. Take away 1/2. Acceleration is, I don't know, but I do know the time is 0.5 hours, and I'm going to square that. So I have 10 kilometers equals negative 1/2 acceleration 0.25 hours squared. This is just now grade 9 mathematics, solving the equation. If I multiply through by -2, I'll get 20 kilometers here. That half disappears. If I divide both sides by 0.25, I get 0.25 hours squared here, and that's equal to my acceleration. So now I've got 20 divided by a quarter, and that gives me minus 80 kilometers per hour squared is equal to my acceleration. Well, what does the minus mean? Well, the minus means the direction. It's east. So I could say 80 kilometers per hour squared east is equal to my acceleration. Now pay very close attention to the fact that the units worked out. If you do unit analysis on questions, if your units work out, then you probably have done the question right. Here is the second question. While driving on a slippery road at 15 meters per second, the driver applies the brakes. It comes to a stop. The braking system limits the acceleration to 0.2 meters per second west, determining the stopping distance. Like before, there is some sort of compass. One way is negative, one way is positive. We're given the acceleration. It's going to be negative 0.2 meters per second squared because it's west. We're given the first velocity. It is positive 15 meters per second because it's east. We know the fact that it stopped. Your velocity is equal to 0. I don't know the displacement. That's what I'm looking for. The other thing I don't know is time. I'm not looking for time. I don't want time. You don't need to use time. So putting in the values, 0 is equal to 15 meters per second squared plus 2 times the acceleration delta t. That's going to be 225 meters squared second squared. I didn't know the acceleration. The acceleration is going to be minus 0.2. So when I multiply that in, I get minus 0.4 meters second squared delta d. Okay. Now again, grade 9 mathematics. Get rid of your term first. Okay. So you subtract 225 from both sides. That equals that. Then I'm going to divide both sides by 0.4. So it gives me negative 25 meters squared second squared over minus 0.4 meters per second squared equals my change in my position or my displacement. Let's look at the units here for 1 minute. Second squareds divide out. 1 meter will divide out. I'll get a number. 225 divided by 0.4 comes out to 562.5 meters equals my displacement. Well, let's just look at our answer for a minute and see what it means. It's positive. Well, what does positive mean? Positive means it was going east. The units worked out, so that makes me think I've done it right. If I were to say this to 3 significant digits, remember we always round to the even number. We have a 5 here. So I would say this is 562 meters east is equal to my displacement. Okay, this has been the first part of this lesson. I'm going to stop it here, and then we'll do the second part of the lesson. Okay?